This is a problem where KSP, the solubility constant for a salt, is kind of incorporated into a precipitation reaction. So I've written out the two salts that have been added together to make this precipitate magnesium fluoride. And they've given us the starting amounts of each of the salts, the mill amount and the molarity. But what we have to do with these problems is figure out which of these is going to precipitate out. And the nitrates will stay soluble. The magnesium and the fluoride are going to get together. And we know that alkali metals, sodium, tend not to precipitate. So I've written it out, and you'll have to figure out sometimes what is precipitating. And I've just shown the net ionic equation, focusing in on what just makes the solid. The question is asking how much of these two ions of magnesium and fluoride are going to be left at equilibrium. So maybe that gives you a hint what you have to set up as an equation. And this is really the first part, is to write out the equation for what's precipitating and figure out how many moles of the precipitate forms. So we can do that. I'm going to go ahead and multiply 0.01 times 0.150. And if you do that, you'll get, for the magnesium, and again, I'm not worried about the nitrates concentration, which would be double that, but I'm just worried about what's precipitating out. You get 0.0015. And you can do the same thing, mole amount, initially for fluoride, and they give us that we have 0.10 and times 0.250. That'll give you 0.025 moles. And of course we start off initially with 0 moles of the solid form. We let the reaction go, and we know that some's going to form to the right. We need to know which of these is the limiting reagent. Well, if we take the 0.0015 and double it, because we'd need 2 for every one of these, you end up with 0.0030. And that's much lower than this. So we're going to go ahead and say the change is just the limiting reagent here would be the magnesium. And of course, for every one of these, we have to take 2 of these. So we're going to go ahead and double this amount because it drags with it as it goes to the right, 2 of these for every one of these. And of course, over here, we're going to just make the 0.0015. Now this doesn't matter too much as far as our numbers in the math that later on we have to use, but it's just good accounting. So at equilibrium, we're going to have close to, we're going to come back to this, 0 amount. Here we're of course going to have 0.025 minus this 0.003, 0.022 moles of the fluoride. And here, of course, we'll have 0.0015 moles. Now, again, the question's asking for not how many moles of the magnesium fluoride you made, how many grams you made. You could work with this number to get grams. The question's asking how much of these two reagents do we have at equilibrium. And do not think we're staying at 0. We're going to have a little bit of this solid cheat back to make some amount of magnesium. And that's what we have to figure out next, is we have to kind of say, okay, from this point, how do I deal with that 0? How do I change that? Well, we know KSP is equal to the concentrations of the magnesium and the fluoride. And of course the fluoride we square because of that coefficient. So what we can do is just plug in what we have from this point for fluoride, and we have KSP given, so we can just solve for magnesium as our x. So we can rewrite this as 6.4 times 10 to the minus 7th. And I'll just have moles per liter. I'll keep everything in molarity. And we're going to then take the magnesium and say x. Now the fluoride, I need to change that to molarity before I square it. So we would take the 0.022 and we divide it by the total volume here. So 150 was combined with 250, so that would give us 400, which is 0.4. And I'll do that math real quick on my calculator. So I get 0.055, and I would square that. And then if you wanted to go ahead and solve for x, which I'm just going to go ahead for time since we're now doing math only, we've kind of set it all up according to the chemical equation. We would just square that 0.055 and then divide both sides by it, and we would have our x value. X is the concentration of our magnesium that we would have at equilibrium. Now, do we know the fluorides already? Yes, we're going to assume that a little bit of fluoride that has been made extra from this weight is very small relative to that starting point we had of 0.055 molarity. Let me say it again. We're not going to say plus x. We're going to just leave that out because the little bit that's coming back this way added to this is inconsequential. Thanks. Bye-bye.